Good afternoon. To your attention is given an article on the topic Application of Big Data Methods in E-Learning Systems. Authors Natalija, Sharonova, Kyrychenko, Iryna, Glib, Tereshchenko and Natalija. Analytics and big data play an important role in the future of higher education. This paper analyzes and practices the use of e-learning technology tools to provide relevant information for teachers and students trying to optimize the learning process. The combination of data processing and analytical training is an aid that will greatly enhance higher education and determine the path for further development in the new educational era. Big data can be defined as the digital convergence of structured data inside databases, as well as unstructured data coming from new sources such as social networks, mobile devices, sensors, smart meters and financial systems. Otherwise, the McKinsey Global Institute defines big data as data sets that exceed the ability of typical database software to capture, store, manage, and analyze. Today, this method allows organizations to capture and analyze any data, no matter what type, how much, or how quickly it is transmitted, and make more informed decisions based on that information. It has been determined that there is much more to learn about how to handle big data like everyone else. But one thing is for certain is that traditional ways of working with data will not lead to success in big data analysis. The variety of information sources, the amount of information, the delay in processing, even the core business models are often in a large data space. Recommendations to use the same old tools under these new conditions are not suitable for data analysis. Data mining research and detection by machine in the raw data of hidden knowledge that was not known, non-trivial, practically useful, accessible for human interpretation. The main stages of solving problems using data mining methods are setting the task of analysis, data collection, data preparation, choice of model, selection of model parameters and training algorithm, model training, analysis of the quality of training. If unsatisfactory, then move to item E or item D. Analysis of identified patterns. If unsatisfactory, then move to paragraph 1, 4, or 5. The choice of data analysis method is based on some features of the source data. In our case, we can distinguish the following features. No prior knowledge of the data being analyzed, since we are in the initial stages of analysis. The number of groups to which each sample object will be assigned is unknown in advance. Object partitioning must take place on a whole set of features, not on a single dimension. The number of methods of splitting a set into clusters is quite large. All of them can be divided into hierarchical and non-hierarchical. Hierarchical clustering combines small clusters into large clusters or splits large clusters into small clusters. Hierarchical algorithms are in turn divided into agglomerative and divisible ones. Agglomerative methods are characterized by sequential integration of the original elements and a corresponding decrease in the number of clusters. At the beginning of the algorithm, all objects are separate clusters. Initially, the most similar objects are clustered. The merge then proceeds until all the objects form a single cluster. Divided methods are characterized by the sequential separation of the original cluster consisting of all objects and the corresponding increase in the number of clusters. At the beginning of the algorithm, all objects belong to a single cluster, which in the next steps is divided into smaller clusters, resulting in a sequence of splitting groups. Non-hierarchical algorithms try to group the data into clusters so that the objective function of the partition algorithm reaches the extremum. A very important issue is the problem of selecting the required number of clusters. Sometimes a number of clusters can be chosen a priori. However, in the general case, this number is determined in the process of splitting the set into clusters. Studies were conducted by Fortier and Solomon, and it was found that the number of clusters should be accepted to achieve the probability that the best fit was found. Thus, the optimal partition number is a function of a given fraction of the best, or in some sense permissible, partitions in many of all possible. The total scattering will be greater than the fraction of the admissible partitions. Based on the information obtained for the experiment were selected algorithms ChPI, DBSCAN, Hierarchical Clustering Algorithm, X means an EM algorithm. Cluster analysis of model data using the selected algorithms showed good results, which is why these algorithms are used for further clustering of real data. One of the objectives of the study is the choice of software for the process of clustering and subsequent visualization of the results. For this purpose, a great deal of work was done to search for existing statistical packages. As you can see, all existing programs can be divided into three main categories: private research, implemented using popular software math packages; expensive commercial solutions focused on corporate statistical research; and a small proportion of statistical packages that are freely available. In order to select the mathematical package for the study, a number of existing statistical processing tools were considered. The Fuzzy Clustering and Data Analysis Toolbox software package from MATLAB provides three categories of functions: clustering algorithms that break data into clusters with different approaches, k-means and k-meanoid algorithms for stable clustering, FCM-CLUST, GK-CLUST and cluster and stable clustering algorithms. Analysis functions that evaluate each fixed partition performed by an algorithm based on indices. Visualization features that implement Salmon's modified method of displaying data in a smaller space. This program is installed as a plugin, does not provide a ready-made interface for analysis, but allows you to further use the functions described above when developing applications on MATLAB. Cluster Validity Analysis Platform is a software tool, also implemented on MATLAB. Based on a user-friendly graphical interface, it includes several algorithms for cluster analysis, as well as the most widely used indexes of their performance. By working in this application, the user is not only able to download their data, but also save the results of work. The undoubted advantage is that the graphical part allows to analyze several algorithms for one index at a time. RapidMiner is a machine learning and data analysis environment in which the user is shielded from all the rough work. Instead, he is invited to draw the entire desirable data analysis process in the form of a chain of operators and run it for execution. The operator chain is represented in RapidMiner as an interactive graph and as an expression in XML. Now more than 400 operators are implemented in the system. Of them, operators of precedent training, which implements clustering, classification, regression and association search algorithms. Pre-processing operators, filtering, sampling, filling in the gaps, reducing the dimension. Operators of work with signs. Meta-operators. Operators of quality assessment. Visualization operators. Data downloading and storage operators. WEKA is written in Java at the University of Waikato and provides the user with the ability to pre-process data, solve clustering, classify, regress and search for associative rules, as well as visualize data and results. The program is very easy to learn, is free and can be supplemented with new means of pre-processing and data visualization. The output can be represented as a matrix of feature descriptions. WEKA provides access to SQL databases through Java database connectivity and can accept SQL query results as output. WEKA has the Explorer A, but the same functionality is available through the knowledge flow component interface and from the command line. There is a separate experimenter application to compare the very root of the ability of machine learning algorithms on a given set of tasks. Explorer has several panels. Pre-process panel allows you to import data from a database, CSV file, etc., and apply filtering algorithms to them. For example, translate quantitative characters into discrete ones, delete objects and features by a given criterion. Classify panel allows you to apply classification and regression algorithms for data sampling, estimating the predictability of algorithms, visualizing erroneous predictions, ROC curves, and the algorithm itself, if possible. The associate panel search bar is concerned with identifying any meaningful relationships between features. Cluster panel gives access to k-means algorithm, EM algorithm, cobweb, DBSCAN and others. Select Attributes panel gives access to feature selection methods. Visualization panel builds scatter plot matrix, allows you to select and enlarge graphs, etc. Thus, after examining several statistical packages, WEKA software package was selected for further clustering process, which contains the selected algorithms and has the possibility to connect to the database via URL. In addition, WEKA is one of the few products that has an intuitive interface and translated technical literature. This part of the visualization is based on two attributes with SIMGRON total along with the x-axis corresponding to the result, along with the y-axis. However, there can be no more than one part of the visualization based on the other two attributes. As we can see, most boys were absent from the two tests and therefore had poor grades in all subjects. Most of the girls with average grades who went to the first test but missed the next one also got into the cluster of section B. Also, we could see that most guys had excellent grades in subjects and wrote the second test. This paper presents data mining in an educational environment that identifies patterns of student failure through associative rule extraction techniques. Association rule analysis was applied to education systems to analyze student outcomes. In this study, the association rules retrieval technique is used to find hidden patterns and evaluate student performance and trends. The EM algorithm is used to find associations between attributes. Students' achievement was assessed on the basis of academic and personal data obtained as a result of one semester. J48 classification algorithms were then used. The data analysis tool used in the experiment was WEKA 3.8.2. Based on the accuracy and classification errors, we can conclude that the J48 classification method was the most appropriate algorithm for the dataset. The EM algorithm was applied to the dataset using WEKA to find an analysis of overall student performance by some of the best rules. Data can be expanded to capture some of the extracurricular aspects and technical skills of students, and to replace them with different classification algorithms to predict student performance. Thanks for your attention.